Today we're going to talk about inequalities, okay? So who wants to read this for us? You don't have to write this down, but let's read it and see where we're going with this. Okay, how about, go ahead, Young. Go ahead.
Our geometry up until now has emphasized congruent segments and angles, and the triangles and polygons they form. To deal with segments whose lengths are equal and angles whose measure are equal, you have to use properties of inequality taken from algebra. They're stated on page 37. In this chapter, you will work with segments having unequal lengths and angles having unequal measures. You will use properties of inequalities taken from algebra.
Okay, so anybody remember something about inequalities? Some of the properties? Yeah.
Greater than.
Right, so inequality symbol consists of greater than, less than, or what? Greater than or? Equal to, less than or? Equal to. So we're going to be talking about those. You guys remember those?
Yes.
When you were solving inequality problems, could you add both sides by the same number?
Yeah.
Does the inequality symbol change?
No.
No. When does it reverse? Anybody remember? Yeah. When you divide by negative, also when you multiply both sides by negative. You guys remember that? So those are going to be, we're going to be talking about those today. So that's going to be important. So before we get going, let's do an example. Everybody think about this example 1. So let's say that we have this triangle, ABC. And I told you that AC is greater than AB. And AB is greater than BC. What can you conclude about AC and BC? It's sort of obvious. You could actually even plug in some number, right? Let's say AC is 10, AB is 7, and then BC is 5 or something. You know? It's sort of obvious. What can you tell me about AC and BC? Grace? Yeah, AC is greater than BC. Would you not agree? Isn't that pretty simple? I'm sorry? Is this transitive property? That's a good question. Is this a transitive property? But I know why you're saying it's transitive property. It sort of looks like it, doesn't it? If we had equal sign or inequality there in between, instead of the inequality symbol. But it's not called transitive. You actually learn what it's called, what this property is called in a minute. Okay, very good. So it's not really a transitive, but I see what you mean by that. Okay, next, what about if I have this? I have angle ABD, and then they're telling us, okay, if measure of angle BAC plus measure angle CAD is equal to the whole angle BAD, what can you tell me about the two angles? It's sort of obvious. What can you tell me about BAD versus BAC? Which one's greater? BAD, obvious, right? Because BAC is part of BAD. What can you tell me about also BAD versus CAD, class? BAD is greater, right? CAD is part of the whole thing. Okay, sort of obvious. Does that make sense? Okay, so that's pretty straightforward. So now, who wants to read for us what we're going with these? Okay, the properties of inequalities. Samantha, go ahead.
The properties of inequality you will use most often in geometry are stated on the following page. When you use any one of them in a proof, you can write as your reason a prop of inequality. Can you see which properties were used in example 1?
Okay, so take a look at example 1. This was the example we just did. Think about which property we used. And they said you could just write a property of inequality. Turns out there are 5 of these properties. We sort of group them together. All those 5, all you have to say for a reason when you're doing a proof, just write what? A property of inequality. That's all you need to do. Sort of easy, isn't that nice? It's got a name too. So that's really good. So let's talk about what these properties are. And that's our main topic today, okay? So let's move on to the next page. So the first property, so these are properties of inequality. Like I said, there are 5 of these, and they're all called property of inequality. Okay. So first one is this: if I have A greater than B, and C is greater than or equal to D, what can you say about the sum of A and C versus sum of B and D? So A plus C versus B plus D. This should remind you of something that we learned already. But if this is true, A is greater than B, and C is greater than or equal to D, what can you say about the sum of AC versus sum of BD? AC and BD, it should remind you of something. Jonathan?
A plus C is greater than B plus D.
You're exactly right. It turns out, if I were to add A, C together and then B and D together, AC is going to be greater than BD every time.
Why is that?
Very good question. What do you mean? Why is there equal to here? Is that what you mean? Okay, good question. How come C is greater than or equal to D? Why doesn't it say C greater than D? Why is it okay to add the equal to sign? Meaning C and D could be equal to each other, right? Why is that okay? Iveta? Yeah, it'll still be true, wouldn't it? Why? Because, Kevin, A is greater than B. So if A is greater than B, you could add same amount to both. The left side will still be greater. Does that make sense? That's why, of course, if it's greater than C is greater than D, if you're just adding the greater ones and then all the smaller ones together, of course, left side is always greater. But even if you're adding the same number to both sides, because A was greater than B to start with, of course, left side will be greater. Does that make sense? Do you see why we have the equal sign here? C could be greater than or equal to D, right? Still works. What does this remind you of? Which property from previous sections that we learned? Josh? Addition property of equality. This will be the same as the addition property of equality if you had equal sign in between these inequalities, right? You guys remember if A is equal to B and C is equal to D, right? A plus C is equal to what? B plus D. But this, what's the name of this property? This is a property of inequality. Okay, that's what we call it. You get what we're trying to say here? All right. Next, let's take a look at the next one. If A is greater than B and C is greater than 0, what can we say about the product of these? So in other words, AC versus BC. What can you tell me about AC versus BC? If I were to multiply C to both sides of this inequality. But that's if C is greater than 0. Jason? So what I'm saying is, what can you tell me about like AB versus BC? If you were to multiply both sides by C, which side is greater? AC or BC? You think it's going to be the same if A was greater than B?
Wait, we're talking about the product.
Yes.
Wait. Never mind.
A to be greater. Would you not agree, guys?
Yes.
Right? Do you guys remember when we dealt with problems involving inequalities, you multiply both sides by the inequality? We didn't switch the inequality symbol, did we? The left side, if the left side was greater, it remained, right? Greater. Unless it's negative, very good. Also, could we divide both sides by C? What would happen if we divide both sides by C? And if C is greater than 0, which side will be greater? A over C side or B over C side? A over C side, because A was greater to begin with. Now, do you think this will be true if C is less than 0? No. It will not be. Okay, so you're right. So here's the second one. We have the same situation except now C is less than 0. Let's write that down. If A is greater than B, and now C is less than 0, what's it mean when it says less than 0? It means C is negative. Okay, then what can you conclude? What can you tell me about AC versus BC this time if it's less than 0? In other words, when C is negative. Do you guys remember what you did when you multiply both sides by a negative number for these inequalities? You reverse the inequality symbol, right? So what can we say for this here? Yachan?
AC is less than BC.
That's right. This time now AC is less than BC. Samantha, what happens if we divide both sides by C? What do you think?
AC is less than, or A over C is less than.
Exactly right. Does that make sense? Is this pretty straightforward? Okay, I'll wait for you to write. Okay, that's fine. All right, may I move on to the next one? No?
Yes.
All right. Now take a look at this. If A is greater than B again, notice all of these, A is greater than B. Okay, that's what we're starting with. But now B is greater than C. What do you think you could conclude? If A is greater than B and B is greater than C. Brianna, what do you think? What do you think you could say? If A is greater than B? That's right. A is greater than C. What does this remind you of, guys? Transitive. Of course, it's not transitive, right? In order for this to be a transitive, you would either need equal sign or congruence, right? By the way, do you see how this was sort of saying this is the property we used for example 1, the first one? Yeah. Right? This is all right. And here's the last one. If A is equal to B plus C, and C happens to be greater than 0. Okay, so you could actually plug in some number. If A is equal to, I don't know, if A is 3, B is 2, C is 1. Would that work? Okay, right? Then 3 is equal to 3, right? What can you tell me about A and B? Now, this is important that C is greater than 0, because if it wasn't, then it's not going to work every time. Nicholas? Yeah, A has to be greater than B, right? Because we said C has to be greater than 0, correct? If you're adding something that's greater than 0 to one side, right? Of course, A has to be greater than B. Is it complicated?
Yeah. So it's everything
Just plug in some number, huh?
Okay, everything one part.
Yeah, this whole thing, if you're using any of these 5 parts, right? 5, you just write A property of inequality. We'll do an example. Yeah, Jason.
So you have to memorize like all of them?
No, all of these have a name.
I know.
But you have to know, yeah, you have to know that all 5 of these, right, mean property of inequality. So if you're using any of these 5, the reason for your proofs or things like that will be property of inequality. Iveta? Okay, last one. Think about this. Last one. Look at last one. Give me an example where A is equal to B plus C. For example, A could be 3, B could be 2, and C could be 1. What can you tell me about 3 versus 2? 3 is greater than 2. That's what we're saying. Huh? Okay, if B is 1, C is 4, A better be what? A better be what? Does that make sense? Okay, yeah. So if B is 2, C is 3, A better be 5, right? And of course, is 5 greater than 2? Yeah, of course, right? That's why we said C has to be greater than 0. If C isn't greater than 0, would this work? No, it doesn't. That's why it's important right here. See, maybe if you're writing this down, maybe you should like highlight it or put a star here. C has to be greater than 0 for this to work, right? If it wasn't, it's not going to work. Right? That's why we have this condition here, okay. Right? If it wasn't greater than 0, it won't work. Right? Any question? Okay, anybody need more time? Let's do an example. Okay, turns out it's pretty simple to use this property of inequality. Huh? Example 2 now. We have this picture here, and I told you, you see this side of this triangle, AC is greater than BC, and CE right here is greater than CD. Okay, if this is true, we could prove that AE, this whole segment, is greater than BD. Okay, how would you do this? Oh, a lot of you. Go ahead, do it on a piece of paper and work as a group. If you don't get it, if you get it, you know, help each other out. Go ahead. If you don't, ask each question. Turns out this proof is not that long. It's pretty short actually. What you have to do is, anybody see what to do first? Of course, I'll give you the first line. I'll give you the given. Okay. Now, what do we do after the given? John? What do you think? What's your?
AC plus C is greater than BC plus C.
Exactly. And what's the reason? Yeah, a property of inequality. Right? That's it. Yeah. And by the way, which one? We had 5 of those. Which one are we using? The first one, right? This is A, right? A greater than B, right? C greater than D, right? A plus C is greater than what? B plus D. Isn't that what we're? Okay. Okay. That's our third step. What do we do next here? Who could tell me? How about Tony? Thank you. Using the segmentation postulate, what are you going to write?
AE is greater than BD.
No, not yet. So here, before we do that, we got to write, okay, Tony, don't we have to say something about AE? We haven't said anything about AE. What's AE made up of? Yeah, and then what's BD made up of? Tony, what's, yeah. So that's when you have the segmentation postulate there. Tony, then what are you going to do next? Tony, I'm asking. Tony, what do you think? Yeah, I'm asking Tony, right? Go ahead, Tony, go ahead. Would it be substitution or transitive? Look, we were using equal sign. These are measurements. So guess what? We could just use substitution. Okay, these are just actual numbers, right? How long they are. So by substitution, we know that AE is greater than BD. Pretty straightforward. I'm sorry? Yeah. Yeah. So I asked you to do this problem, right? How many people got this right? Is it okay if I switch this second and the third step? Yes, it doesn't matter, right? It doesn't really change anything, right? Any question? All right, good. Here's example 3 then. Yeah, write this down. And can you show, if this is what we have, angle 1 is an exterior angle of triangle DEF, can you prove that angle 1 is greater than angle, measurable angle D, and measurable angle 1 is greater than measurable angle E. If you can, go ahead. Now, let me give you a hint. Do you guys know anything about an exterior angle? What can you tell me about an exterior angle? Let me see. Who have an eye? Yes, Nicole? I mean, sorry. Naomi? Sorry. Okay, huh? Exactly. Nicole is correct. Naomi is correct. Angle 1. Angle 1 is what? Naomi, what? Angle 1 is? Equal to? Measure angle D plus measure angle E. You guys remember that?
Yeah.
Do you think that's going to be helpful for us to prove this?
Yeah.
Okay. So, Naomi told us a key step. You need that, okay? Otherwise, you can't prove. Go ahead. Everybody try.
Yes,
All right, here we go. So, first, I'll give you the first line, given. Okay, so angle 1. By the way, do I actually have to write the given if they give you this picture?
Yeah.
Yeah, this time it's okay. But if you did, that's fine. This is fine. I mean, then let's say that we did that. Okay, for given angle 1 is an exterior angle, right? All right. So then we just talked about this. If you know that angle 1 is an exterior angle, what can you tell me about angle 1? We just said this. Somebody that I haven't picked. Dylan, what can you tell me about angle 1? Exactly. Measure angle 1 plus measure angle 1 is equal to measure angle what? E plus. Correct. Okay, what's the reason? What do we write as a reason? 1, 2 people? We just talked about this. What's the reason? 3? You don't know how to say it? 4? Who haven't I called? Josh, what do you think?
Exterior angle of a triangle equals
Some of the other two angle? That's not the words we use. Because if you say other two angle, it's not really clear. Yeah. That's correct. So you need to remember this theorem. Oops. The measure of an exterior angle of a triangle equals the sum of the measures of the what? Two remote interior. Those are the two remote, not like angle DFE. That's not what we're talking about. Remember, remote means it's far away from it. It's not the adjacent angle, right? So the measure of an exterior angle of a triangle equals the sum of the measure of the two remote interior angles, okay? So if you forgot about that, write it down. I'll wait. So then what do we do next? It turns out from here, we could say that angle 1 is greater than measure angle D, and measure angle 1 is greater than measure angle E. Anybody know why? Okay, Nicole, what do you think? That's correct. It's because of the a property of inequality is your reason. Which one of these? Okay, let's go back. How can we say this? Let's go back to what we had here. Which one of these are we talking about? The last one, right? But how come it says last one A, if A is equal to B plus C and C is greater than 0, A is greater than B, right? How come they have both of these? Look, they said with that step, they said measure angle 1 is greater than angle D. Measure angle 1 is also greater than angle E.
It's the same thing.
Yeah, why is it the same thing? Tony?
Because the measure of angle cannot be negative.
That's exactly right. Measure of angle D, is that angle, you could consider that as C. Is that greater than 0? Yeah, so therefore, 1 is greater than E. Now, also E, can we just consider E as the C? Isn't angle CE greater than 0?
Yeah.
Therefore, angle 1 is greater than measure angle D. Does that make sense? So that's the proof. Any question?
Is this it?
Well, actually, it turns out this example 3 that we just did is a theorem. Can somebody guess what this theorem says before I show it to you? Anybody want to guess? What do you think this theorem will say? Because this example is the theorem that we're going to talk about right now. 1, 2 people, 3, 4. Grace, what do you think? Actually, yeah, okay, good. Yeah, okay, that's exactly. So it has a name, isn't that nice? Yes. It's called the exterior angle inequality theorem.
Oh my god.
That's not bad. What it says is exactly what you expected. The measure of an exterior angle of a triangle is what? Greater than the measure of either remote interior angle. It means, right, for one of those. We're not talking about some of those or anything like that, right? Be careful. The other one was talking about some of the remote interior. Is this talking about some of the remote interior? No, it's saying is if you were to compare the exterior angle versus one of those remote interior angles, right? it's going to be greater. It's going to be greater for either one of those, right? So this is always going to be true. Any question? Does this make sense? Right? It makes sense, right? This is sort of obvious.
Wait, isn't this already a theorem?
Yeah, it's a theorem. So and it has a name. I'm sorry?
It's already a theorem.
Yeah, that's what we just proved. Right, we just proved this theorem right up here. Right? Yeah, the proof we just did was the proof of this theorem. Any question? Does this make sense?
Are we using that?
I'm sorry?
Are we using the theorem for
Maybe.
Probably. Okay. Any other question? Are we good? Does this make sense?
Yes.
Okay, go ahead and write it down. Okay. Good.